Hello, welcome to Nobel Tutorial. Welcome to this session, a session that is aimed at seeing how linear interpolation can be used in approximation of values that lie between given figures. Remember, interpolation only deals with the computation of figures or of values of unknowns that lie within given figures. Say if you're given y0 and y1 and someone told you to find the figure in between here, say ym, the figure here, we just locate it, or we just find the estimation. We cannot get an actual figure because this is numerical methods. We get estimations. So you get an estimate of this figure. The best way to do that is using linear interpolation. Wherever we are looking for figures that are not interpolated, but they lie within two successive given figures, linear interpolation is the best application to use. Let's enjoy this session as we learn. Now, linear interpolation would say it deals with computation of unknown values that lie between two given values. So when we say whenever figures are not tabulated, but they lie between two successive figures, then we use linear interpolation. Consider a function y equals f of x. This function, just imagine if, say, the function values if x and y and x1, y1 are the values of this function. Now, how will it be? Look at this. If this is your x-axis and this is your y-axis, say this function y equals f of x. Let's assume this is the function. So in this sense, you have this as function y equals f of x. If this is the case, and we say the first value for y, or the first coordinate is x1, and x1, y1. Let's assume this being the x-axis. So this is, say, x. The corresponding value in the y-axis shall be y. So if this point is point A, after locating this, then there is this other value where I have, if this is, say, the value x1. If this is x1, this will be the corresponding value of y and shall be y1. In this sense, these are two successive x values. If you want to locate a figure, so you can name this one B. If you want to locate a figure in between here, any find x estimate, remember we are not looking for a real value. We are looking for an estimate of a figure that lies between these two successive x coordinates. So let's say this figure is around here. Say at point x0, and the corresponding value y shall be y0. If you label this one maybe C. Remember, if we make a line here that comes slowly and touches this point, you join these 2 points. And if you do, also join this side that you can create a triangle. Do you see this triangle? If you name this one, say M, point M, and you name this one, say point N. Now we have triangle AMB and triangle ACN. If you have these 2 triangles, now we use similarity of figures to express the gradients of this. If you use the gradient way, then we shall have from the graph, from this graph, we shall have, look at this, you have AM and ACN is a triangle, and ABM is also a triangle. So we say we are going to use similar figures or similarity of figures. When you have this, we shall have CN, or somebody can possibly say NC divided by MB is equal to AN divided by AM. When you try to look at the coordinates here, A and C, from N to C, C is y naught in terms of x and y, minus y x naught. So you shall have y naught, this, minus y, divided by. Now, when you have MB, this is MB, it is y1 minus y. y1 minus y. This should be the same as, when you look at AN, it is A to N. You have x naught minus x. Divided by AM, which is x1 minus x still. x1 minus x. When you look at this is the formula that we use to calculate a figure that lies within or in between two successive values that are given. This figure is never real. It is an estimate. It is not an actual value, because with the numerical methods, we deal with only and only estimates. This is how best you can prove the linear interpolation. So the only thing we are dealing with now is having an example on how it can be done. When you look at such information, please, when you find it, share it with people that may need the help. Enjoy as you learn.